Hello, welcome to 5.2. The title is called Statements and Qualifiers. A statement is a sentence that is either true or false, but not both. So let's talk about that. A sentence doesn't have to be true or false. An example would be, shut the door. It's a sentence, but it's neither true or false. Some sentences are either one, and sometimes it's hard to tell. We're going to do some examples here and see if we can come up with things that are true or false or neither. So we need to talk about whether these statements are true or false or neither one. So x plus 7 equals 4. Not a statement, true statement, or false statement. It's not a statement. And the reason why is because we don't know what x is. Now, can we solve for x and say, yeah, we know what x is, but we don't know unless x is a different number than what it is to make it true. You know, x can be any number. That's what variables mean. So if x is 5, okay, then this would be a false statement if we knew what x was. But since we don't, we can't determine whether or not it's true or false. 3 plus 5 equals 6. Not a statement, true statement, or false statement. False statement. I think we all can know that this is not a fact. This sentence is false. Which one do you think? 1, 2, or 3? Yeah, it's not a statement. We have no idea if the sentence is true or not. It's telling us that it's false, but we don't know. We don't know the answer. So a statement, remember, it is either true or false, but not both. So give yourself a guess and see what you think. Okay. The reason why this is a true statement and not the other one with a variable is because they are equal. No matter what x is, okay, no matter what value of x we put in there, both sides are equal to each other. Okay, so remember, this is just distributive property. So if I have 3x minus 9, it's going to equal 3x minus 9. It's going to be true no matter what. So be really careful with how you analyze these things, okay, because they are logical. Alright, so in mathematical logic, statements are usually symbolized by letters such as P or Q. So, statement P says dogs have fleas. Statement Q says baseball is fun. Alright, these are just letters that symbolize the statements. A negation of a statement is the opposite. So, geometry is fun, which is a true statement. Okay, I know you guys want to argue about that, but I'm telling you it's true. So, if geometry is not fun, would be a false statement. So, in symbolic logic, the way we're going to write that would be the first statement is P, then the second statement is not P, or the negation is that little squiggly line, not P. Okay, we're going to be talking about symbols for symbolic logic here a lot over the next couple sections, so it's important that we understand right from the beginning what we're even representing with our letters. Okay, so in logical reasoning, the words all and every are represented in an upside down A. All is called a universal qualifier. Okay, or I'm sorry, quantifier, universal quantifier. So if I say all A are B, then that's universal. If I say no A are B, then that's also a universal quantifier. It's just the negative version of it. So the opposite, or the negation of a universal quantifier, is that you have to show that the statement is not true for all. And if it's a negative, like none are, then it would be, you would show that a statement is true for some. So for all P, okay, where the statement is all flowers are pretty, the negation is not all P. Okay? So there exist flowers that are not pretty would be an opposite or a negation of all flowers are pretty. Also would be not all flowers are pretty. Okay, so I'm saying if all flowers are pretty, then I'm saying not all flowers are pretty. We could also say some flowers are not pretty. Okay, so this is the most common way to do the negation of a universal quantifier, and it's called an existential. Okay, this is still a quantifier, but it's an existential quantifier, which is this backwards E, and it implies one or more. So, for example, to negate an existential quantifier, you have to say that it cannot be true for any, or you're saying none. Okay? So there exist dogs that have fleas. So another way to actually phrase that would be some dogs have fleas, right? And to negate that would to say no dogs have fleas. Okay, so here are some examples. If I say girls are logical, okay, I know we have a primarily male class this year, so you'll have to bear with me. You're being taught by a girl. So, if P is girls are logical, then the universal quantifier for girls are logical would be all girls are logical. Now, if I'm going to negate that statement, so I'm negating the universal quantifier, I'm going to say not all girls are logical. Okay, now I have to come up with the existential quantifier for girls are logical, which would be some girls are logical. You might be likely to agree with that more, I would hope. And now I'm going to negate that statement, which says no girls are logical. Alright, let's do more of a boy thing. Cars are expensive. Most boys like cars. So, and you'll agree, they're expensive, especially this year, because I think some of you are going to either try to buy your own or, you know, have to pay for insurance or something later on. So, cars are expensive. Now, I'm going to have to do a universal quantifier. All cars are expensive. Okay, now the negation would be not all cars are expensive. Now I've got to change that to an existential. Some cars are expensive. And again, no cars are expensive. To negate some, you have to say none are. And if I'm going to negate all, then I'm going to say some are not. Alright, so that's the entire lesson. There are some more examples in your book. On page 167, there's a little blue box that has P and not P. Those may or may not be helpful to you, but I really want you to think about things you already know. Okay, so you already know about segments and triangles, and I'm going to have you do some just writing what this sentence says in symbols. So the only symbol we didn't talk about that I think will be helpful for you is to use this backwards element sign, and I want you to use that for the words such that. Okay, so you're translating these two sentences into symbols only. Okay, do your best, right? It's about participation, not about correct responses. So I want you to submit those to me through email. You may, in this case, it's probably going to be easiest to do a picture again and take a picture and send it to me. And I will reply. See you in class.